Welcome to Why Projects Fail to Meet Water Quality Requirements. This is put on by the Pacific Northwest chapter of the International Erosion Control Association. I'm Dave Jenkins, the chapter president, and I will be presenter today. Please visit our website for information on membership, upcoming webinars, our YouTube channel where we post the webinars, and a bunch of other stuff. So PNW-IECA.com, .com. Learning objectives. To identify potential project failure points, develop procedures and policies for preventing project failures, create and review project plans and specifications that guide the project to compliant success. A little bit about my background. I retired last year from the Port of Seattle as their first erosion control stormwater engineer. The project I'm going to talk about actually led to the job creation that I had, and changes in the construction program, environmental program, and this will be lessons learned from that project. That project was the North Employee Parking Lot, or NEPL, which was constructed in 1997-98. This was built to provide parking for port employees to free up space in the parking garage for traveler parking. So this is employees and for both for the Port of Seattle and for the airlines, the vendors in the terminals and such. So needed to free up a lot of space. Overview of the project involved clearing and grubbing of 40 to 50 acres and excavation and fill of about 45,000 cubic yards. There was a rock wall construction portion, installation of erosion control measures, of course, seeding. There was a stormwater detention vault built, stormwater drainage facilities, and then asphalt treated base in some areas and crushed rock base for future cover by asphalt. Not too long in the project, this happened, and I'll tell you why. This is some of the cleanup after the fact. The worst part of this for the port was local opposition to a project the port was planning on building, which I'll touch on. And this was a headline from one of the local newspapers: "Port fined for Miller Creek discharges." And a great quote: "If they can't manage a simple parking lot project, how can we trust them with 26 million cubic yards of fill for a third runway?" And actually, I don't think it was 26 million cubic yards. I think it was 26 million tons, probably. So this was the third runway project, which was years in the planning, involved bringing in a lot of fill, filling wetlands, relocating, a bunch of stuff. So this project needed to be completed, and the neighbors weren't happy about it. So we had to do something. So I'm going to go through some reasons why the project failed. And these are also lessons learned for the port. They're not in any particular order. So number 1 isn't the biggest issue. Number 10 isn't the least. So I'm going to go through each of these. And before I get started, I just want to say that most of the focus, I think, on erosion controls is on the BMPs, that if there's a failure, it's a failure of best management practices, or it's the contractor's fault. And my contention is that if there's a failure on a project, it's a contract, it's a design issue ultimately. So the contract is probably flawed, or the process of developing the project and putting it on the street has flaws in it. So it's kind of my philosophy, and that's what I'm going to touch on quite a bit. So this is the pay items for erosion control on the project. You can see straw bale barriers, which I don't think are used anymore. but all of these really are sediment controls. And then we get down to the bottom and you see in red, sediment pond maintenance. It's a lump sum item. Contractor bid $2,000 on that. Well, we'll touch on that more. And then the last one is emergency erosion control measures, force account, which is set by the owner, so $40,000. So keep those in mind as we go forward here. And then this is the payment language in the contract. And it's pretty light. Payment for stormwater pond maintenance shall be full compensation for providing all labor, materials, etc., to maintain efficient operation. All other costs necessary to implement the temporary erosion sediment control facilities shall be considered incidental to and included in. Incidental is a bad word to me, and it works on some projects. It definitely does not work on big earthwork projects, in my experience. So this is a major flaw, I believe, in the contract to do this, and I'll show you why here in a minute. So a question comes up on that pay language. If the contractor is required to develop an erosion plan, how's that being paid for? How are plan modifications paid for? BMP inspections, stormwater monitoring, additional BMPs, stormwater pond construction. There's the language for maintenance, but nothing for actual construction. So this tells me that all of these items are incidental to other items, whatever that means in this contract, which just opens up for potential fight between the contractor and the owner, but also there's not a lot of direction here for what the contractor has to do. So a solution, this is what the port does now. They have a very extensive section for payment for erosion control. They have an erosion control spec called TESC Plan and Execution, and it is going to be paid lump sum. So the contractor is going to bid this, and it covers pretty much everything. So labor, equipment, inspections, plans, record keeping, et cetera, et cetera. And then if appropriate, unit prices are also included in the contract for measurable items. So silt fence, hydroseed, things like that. And probably 99% of the contracts the port does will have a force account item or contingency item specifically for erosion control, which gives the project engineer a lot of flexibility as things come up, which always happens on a project. An example, actual project example, in 2015, the port did a ground up reconstruction of the center runway. So complete removal and replacement. I believe it was a $50 million contract, 54. So this is what the contractor bid for the TESC plan and execution, 1.5 million. It's a 500-acre project. It's a very short duration for several reasons, but so this is definitely an appropriate bid amount for this project. Next reason is contingency money. So I mentioned the $40,000. The port, when they are putting a contract together, when they talk about force account, how much to put in there, rarely is there a number $10,000 and below. The average is probably $20,000, $25,000 at a minimum, and it goes up. So depending on how many acres, risk factors, time of year, how many wet seasons the project's going to go through, the number keeps going up and up. And when I was helping put together packages, I would tell the project manager, I want as much as you're comfortable with. So on this NEPL project, I probably would have said I want at least $100,000, maybe $200,000 for force account. On the 16 Center project, the force account was set at $500,000, so about 1% of the total project cost. I've tried to figure out, and I know a lot of people have tried to figure out what percentage you should put in for this in a contract, or what percentage you should figure your erosion controls are going to cost. And I don't think there's a way to do it. So what I've found, on the larger the project, the percentage goes up. So here's 1% on force account. On the lump sum, the contractor bid, it was what, 3%-ish. And that's pretty typical from what I've seen. That's what you would probably want to see, is about 1 to 3% on a large project. So on smaller projects, it gets difficult and messy. So I just ask for as much as the project manager would give me. Next reason, inadequate specifications. I'm going to spend a little bit of time on this one because this is really the guts, I think, of the problem, or the gist of the problem. So your Latin lesson for today is this word, contra proferentum. This is a concept that goes way back in contract law, I believe back into English common law, possibly before. What it means is against the offerer. So who is offering the contract? That would be the owner, and in this case, it would be the Port of Seattle. So if there's any confusion, if there's a lawsuit on a contract, the judge is going to lean toward the contractor. So against the offer. So you have to be really clear in your specs with erosion control to get what you want and to avoid issues. So one of the big issues with specifications that I've seen is people put in permit language as is. Now, and I'm not talking about as a reference document. That's a good thing. So any environmental permits you have should be included in a contract as a reference document, so the contractor sees everything. But as far as compliance in a contract, permit language and contract language are two different things. Permit language is general. It's got to cover every possibility. Contract is very specific and deals only with your project in these circumstances. So they just really don't mix very well. Example of permit language. These are taken right out of the Construction Stormwater General Permit in Washington State. So maximum degree practicable, if possible, to minimize, which is my favorite, as thoroughly as possible, as necessary, in a manner, if necessary, as needed. Now, none of these are contractual. These are open to interpretation. So if you tell a contractor to minimize something, it's really up to them to decide how much to minimize and what that word means. So back to the NEPL specs. These are some examples taken right from the contract. Cut and fill slopes shall be constructed in a manner that will minimize erosion. I don't know what that means. I don't think the contractor knows what that means. Now, the second part is better. Slopes shall be tracked, seeded, and mulched within the time constraints indicated on the plans. I don't know what those are because I don't have the plans. I had to piece this together 25 years after the fact. So I didn't have all of the information. So the second part is not bad. The first one means nothing in the contract. Another spec from the contract, all temporary BMPs shall be inspected, maintained, and repaired as needed, which isn't too bad, to assure continued performance of their intended function. Now, I don't know what that means exactly. Continued performance of their intended function. What the port spec says, the contractor shall inspect all TESC best management practice daily during work days, and anytime half-inch of rainfall has occurred within 24 hours on weekends, holidays, and after hours. So very specific. Contractor knows exactly what they're bidding. They know exactly what there is expected of them. Other NEPL spec, where construction vehicle access routes intersect paved roads, provisions shall be made to minimize the transport of sediments onto the paved road. So, and this is language that's pretty close to what's in the permit. But again, it's the contractor's choice on what minimize means. It's not specific in the contract. So what does the port say about this? And this is something that we learned very early on in the third runway project, because we had trucks running up to 20 hours a day, up to 6 days a week, thousands and thousands of haul trucks bringing dirt in and leaving. So any small amount of dirt on a truck tire times thousands is a lot of dirt on the road. So we just said, we don't want to see it. Very specific. It is possible to meet this. We found out, but this is biddable. Okay, I can't have any track out. What am I going to do about it? The contractor's thinking. So what the port says, I won't read all of it, but the wheel wash shall be high water pressure, low water volume system, long enough for 2 full tire rotations, spray nozzles directed all over the place. So this really narrows it down. Contractors got to put a wheel wash in. It's a specific type. There's not a lot of them that will meet this spec, but it works. It's an effective spec. What that meant on the third runway project is the port and the contractor got together. The contractor designed this and the port paid. This is 120 foot long, which is what, a 6-7 tire rotation wheel wash. This is what was necessary to meet that spec on that project. Another spec from NEPL regarding the stabilization of denuded areas, the contractor shall phase clearing and grading activity to expose the least area of soil for the shortest possible time. Again, what does this mean? And as I'll mention a little bit later, the contract time was 75 days. So how you're going to do 40 to 50 acres of clearing, grading, and fill without exposing the entire area, I don't know. So what's a solution to all this? Say what's expected and pay for it. If something's added after the contract award, of course, it's a change order. You're going to have to pay that way. A lot of times there's a repeating of environmental conditions, like that's going to be more, let's provide more emphasis, and the contractor's going to know it's important. Waste of words, be concise, don't preach or teach, which I see a lot in environmental specs. Just say what you want and then pay for it. No permit language. And this is one I personally hate, is putting specs on plan sheets. Specs should be in a spec book and plans should be plans. It gets confusing to me, unless it's a really small project where it makes sense. But on larger projects, putting specs on plans, I think, is a bad idea. Okay, next issue, unbuildable erosion control plan. This is the main erosion BMP for this project. And if we were doing a live thing, I would ask you all what you see the problem is with this. First of all, everything on here is sediment control, which has its own issues, but how do you build a sediment pond to control water on the top when you have to fill 90 feet? What do you do in between? So this is problematic right here. What we would do now is we would design this with a construction stormwater chemical treatment system with conveyances to get dirty water to that. In addition, a sediment pond reduces reduce sediment load. It will not reduce turbidity, and that's what we're generally regulated on. reliance on sediment controls. This project, the main focus was sediment controls, as I just mentioned. Sediment controls are important, but they should be considered a last line of defense. And on this photo, the amount of sediment that's built up behind the silt fence. My personal opinion is if there's any sediment behind a silt fence, you've got a project management problem. There shouldn't be sediment built up behind a silt fence. You should be managing the erosion upstream so that doesn't happen. So this is a real failure, but you need to use a mix of erosion control BMPs and not just focus on sediment controls. Now, what's the problem with sediment controls in a sediment pond? You've probably all seen this, but settling time for various soil particles. You can see silt, 107 minutes, almost 2 hours. Colloidal particles, 207 years. I don't know how they figured that, but probably nothing smaller than possibly silt, depends on how much water's going in, but you're going to be looking at fine sands maybe is settling out in a temporary sediment pond. But if you're regulated on turbidity, the colloidals are causing that, and it's not going to settle out. So that's the issue. An example of that is this stockpile that was built for the third runway. Before construction started, it was just to bring fill material in because it was so hard to get at the time. So this is the top of the pile, and I'm going to show you some water samples along the flow stream. This is water coming off the top of the pile, which is kept uncovered because material is coming and going. We've got some nice BMPs. We've got a berm around the top and pipe slope drains and such. The slope has been track walked and hydroseeded. There's silt fence at the base. There is erosion built up before the grass grew. But anyway, so the water is going down through the pipe to the silt fence. It's leaking through the silt fence across a grassy area into a grass-lined, vegetated and blanketed ditch that then drains cross culvert to a stormwater pond. So depending on where you are on the pile, the water is traveling a quarter to a third of a mile to get to this point. Now, samples are taken in 3 locations. Number 1 is what's taken off the top. 2 is what's going in the cross culvert. So it's mixing with some clean runoff from the roadway, which is why it's a little lighter. And then number 3 is what's draining out of the stormwater pond. None of these turbidities will meet requirements at the Port of Seattle. And 1 and 3 definitely wouldn't meet the construction stormwater general permit benchmarks in the state of Washington. So all of those BMPs, turbidity is not reduced significantly. Now you can see the sediment load is reduced tremendously. So I think that's a good example. The only way to take out turbidity, one of the main ways, is some kind of treatment. So active chemical treatment is what the port relies on primarily. So solution, focus on turbidity reduction if that's what your permit requirement is for turbidity. Focus on that. From the get-go, from project design, how are you going to achieve that? And then some basic stuff. Keep offsite water from entering the project. Keep project water from leaving, of course. Manage process water, so concrete washout and things like that. And then manage sediment track out. So these all need to be thought about during project design and how you're going to address them. This was an interesting issue I found on this contract. The contract was let really late in the season. And one of the main reasons that happened was there was an electrical package as part of this project, and it was a very small package. And design wasn't finalized. And the designer kept going back and forth. I don't know what the issues were, but the contract was not awarded. Actually wasn't put on the street until that was resolved. Now, in a big dirt job like this, you don't want to be held up for any reason if it's going to push you into the wet season. So that was a big flaw. solution to that, here's three possibilities: an addendum to the contract, a change order to, pay extra, accelerate the electrical work, do something, or separate it out of the base contract and bid it out separately. There's probably other solutions to that, but don't let, when you're putting a package together, don't let not that electrical is secondary, but in this case, it was a very small portion of the project and shouldn't have held it up. Another reason, don't let the contract out at the end of dry months. So what does that mean in the Seattle area? The dry months for sure are May through September. You can probably push it into April and sometimes into late September, but to really be safe, best time to construct big dirt jobs is May through September. So keep that in mind, and look at the rainfall. Look how it ramps up. So July is just under 1 inch. September is just under 2, and then you almost double up to 4, etc. So if you're still working in September, you're looking at some problems. So here's the actual timing. The final bid package was finalized in mid-June. The engineer signed it end of June, was awarded, and the contractor signed sometime at the end of June. Contractor submitted an erosion plan middle of July. The port commented and returned within a week or so. Notice to proceed was issued in August. I don't know the exact date, and the rains start in September. They had 75 days to complete. So on the right here, the standard recurrence interval storm events in Seattle, at least at the airport, a 2-year 24-hour storm event is 2 inches of rain, or recurrence interval of 2 years, 2 inches of rain. So that sediment pond that couldn't be built early in the project on this was probably designed to contain a 2-inch storm event. Now on the left, I went back in old records and found that in September, there was an event on the 16th and 17th, so 0.73 and 0.67, so nowhere near the 2-year event even. And both of those storms should have been contained in that sediment pond. The average for September was 3.26, but it was a dry year, and they only achieved, 1.5 inches. And same in October 30th, 0.87. So these are not big storms, and shouldn't have caused problems. So what's the solution? When you're putting a package together, think of all of the timing. And these are kind of wrong. I put bid package finalized in January if you want to meet the dry months, April through September, or May through September. This actually should be bumped back a couple of months. So you should be awarding by December, awarding the contract. And then that gives, there's going to be addendums, there's going to be questions, things are going to come up, there's mobilization, all that. And the port has a lot of pre-notice to proceed submittals that have to be accepted by the port from the contractor before NTP. So it can take 6 months, but 4 to 6 months is fairly typical. So if you want to start in May, you've got to hit the ground. You've got to be mobilizing in February, March. So design was a problem on this one. Now there's probably nothing wrong with this design. These are a couple cross sections of the fill for the NEPL project. Pretty standard actually. But what that meant, the contractor built the slope, and then what do they call that? Trimming the batter to get to the final grade and slope and such. So this is just rough fill at this point. And I should point out, there were no specifications for seeding and hydroseeding specifically. So that was left as incidental to the earthwork, basically. There we go. So this is a solution, if you can do it. This is a design that the port developed for third runway early on. It's not what the final slope looked like, but it's what the initial slopes looked like on the project. So 2-to-1 elevation of about 20 to 30 feet, and then a bench that's sloped in so drainage doesn't go over the face, and it's hydroseeded. It's complete. And then they start the second lift up to the next bench, and then the third. And then notice at the top of the slope, there's a berm. So it's designed specifically to prevent anything from going over the side. And it's also designed to stabilize as you go, so you don't have long runs of slope that are just dirt. So this is what that looks like. And you can see the brown graphs on the bottom. So that was hydroseeded quite a while ago. And then the upper two hydroseeded early or later. So another example of that, this is a different area. Well, actually you can see the same fill kind of at the top center here. It's phased. So in the bottom section here, phase one was the clearing and grubbing, putting silt fence in, clearing and grubbing to build stormwater pond and basic drainage facilities. And then they start filling. So phase two, hydroseed it, and then phase three, hydroseed it, and then phase four. So that's how a big dirt job should be done to avoid problems. Another reason, and I mentioned this earlier, if you've got a big dirt job and you know you're going to be going through rainy season or seasons, in the Northwest, construction stormwater treatment is the way to go to meet turbidity requirements. I just don't know of any other way. So this wasn't really available on the NEPL project. This is much more sophisticated than what was available at the time. So it's kind of not fair to put this on NEPL, but it should be considered in design. In the 16 center runway reconstruction, an existing stormwater vault out at the airport was reconfigured to take almost all of the water from the project during construction and hold it in the yellow area for the stormwater treatment system that was in the blue area, and then clean was discharged. So this worked out really well. This isn't something that can happen all the time. It was a fluke of how the drainage systems work out at SeaTac Airport that this was possible. But think about, just think about the water when you're putting a package together. Where is it going to go? How much am I going to have to deal with? What condition is the water going to be in? How am I going to convey it from my work area to someplace that I can treat it? All of those sorts of things. And the last but not least is phasing. So this is not a port project. This is actually near my house in Port Orchard. Note the date on this, October 23rd, and think of the rainfall, average monthly rainfall chart I showed earlier. So October 23rd, this is 80 acres of open bare ground. This is a nightmare waiting to happen, and it actually was a nightmare that did happen. So people were told to leave their homes because there was a high risk of failure from stormwater ponds overflowing and slopes failing. It hammered a wetland, just really problematic. Big fines, shutdowns, things like that. So what's the solution to this? Work smaller areas. Clear all of the area, but only grub small areas at a time. So, cut the trees down. That's one contract let for a logger, but only rip out everything else in areas that you can actually work. So complete the smaller area to stabilization, and then start another smaller area. So in the case of this project, 80 acres, they could have broken this up into easily 4 20-acre sections, 20 to 25 acre, which even though they got a late start on this, they could have gotten to stabilization and then started building houses that winter or the early next spring. This job essentially was shut down for 2 years. So no houses were built. Once you have one of the smaller areas, say the 20 acres completed, then you can start building houses, start selling lots and building houses. So generating income while you're continuing on the project. So continue on to the next smaller area. So, thinking about money, you think about efficiencies. Yeah, it's best to get somebody in there and clear and grub and grade the whole site. It's not necessarily the case. So just something to think about again in design. And this project really needed a treatment system, more than one actually, to be able to work. So in conclusion, most BMPs are not effective for turbidity. The only really effective ones, facetiously, asphalt and concrete, but vegetation, heavy mulch, things like that are effective. It's all about managing water. So from the get-go, when you're putting a design together, when you're putting a contract together, it's for erosion control. It's not about the dirt, it's about the water. So think about how much water you're going to have, how much rainfall, and how you can minimize issues with that. There's that word I hate, minimize. And it's all about plans and specs. It's not about the permits. It's about the plans and specs. If it's not put in the plans and specs appropriately, the permit is not going to be complied with. So got to keep that in mind. It's all about plans and specs when it comes down to it. Got to pay the contractor, no hidden charges or fees, as they say. So make sure they know what they're bidding and how they're going to get paid. Don't put permit language in. If you want it built a certain way, design it that way. Be very clear. If you know it's going to be muddy on the site, there's no way around it. You're going to be working through winter and have a lot of bare soil out. You have to spec a tire wash. No getting around it. If you know it's going to be rainy and muddy and working through winter, spec treatment. Do these up front so the contractor bids these in the original package. Otherwise, you're looking at big change orders. I could do a separate presentation on this next one, develop a project philosophy early in design. And again, that goes back to the water. The philosophy meaning, what are you going to do with the water? How are you going to deal with the water? What's the most important thing on a project related to compliance? How are you going to achieve that? So really sitting down with all the appropriate people. If you have a construction group, get the construction people in there with the environmental people and sit down and talk about what exactly needs to happen. And lastly, plan for contingency. So there's always contingency money in a contract for other things. Have a specific contingency for either environmental compliance, permit compliance, erosion control compliance, whatever, because things always come up, as you know. And that is it. And why is this not? There we go. Any comments or questions? And let me open this up. You can either put in the chat if you have comments or questions, or I think I can open up the I always forget how to do this. I guess it'll have to be chat because I can't remember how to do how to open up the verbal to everybody. So if you have any questions or comments, I didn't put my email address in here, but if you think of something later, you can email me at sheetflow@yahoo.com. So sheet flow like sheet flow, as opposed to real erosion or gully erosion. So sheetflow@yahoo.com. you can send me a comment or question, whatever. So, and with that, I'm going to close out, and thank you all for attending. This has been recorded and will be uploaded to our chapter YouTube site, which can be accessed through our website. So PNW-IECA.com. And thank you all, and hope you have a good day.